Hello guys, welcome back. This is Krishna and welcome to my YouTube channel. So in this sequence, yesterday we talked about the architecture of neural network, right? Means what is input layer, hidden layer and output layer we talked about, right? But today we will talk about a specific one neuron only, which was available inside hidden layer and output layer. So I will talk about one specific neuron, like what kind of working behind a specific neuron inside a neural network. I will talk about that. So let's go to Google Colab Sheet. I just want to show you using a drawing because I'm using Google Colab Sheet because there we have headings, right? So I mentioned heading over there. So that's why I'm going to Google Colab Sheet. But this is all about theoretical part. Means you guys have to understand. In the interview, many people ask like, oh, what neuron actually perform, what neuron actually do inside a neural network. So you guys have to be a proper understanding of that before going further. And that's why I just thought that this concept is very much important, and that's why I'm creating a video on that. So this video is dedicated like what happen inside a single neuron which available inside a neural network. Means in a neural network there may be 100,000 lakhs number of neuron, but what is happening in single neuron, in this video I will talk about that. So let's go to Google Colab Sheet. So I just want to recall you guys, like yesterday I created some sort of two input layer, two neurons in hidden layer, and one I mentioned output layer. Okay, so this is one layer which is hidden layer, but it has two neurons, neuron 1 and neuron 2. This is called input layer. So this is like a first input layer where I was passing x1 and here I was passing x2, and these all was connected to each other, right? Yesterday I have shown you these things, and they all have assigned some weight like w1 1, w12, w21 and w22, some sort of image I created last time. So I was not talking about these things today. Okay, I'm just talking about single neuron, but I just want to show you like what I discussed yesterday, and that's why I'm creating this image. Okay, so this is like again w31 and it is w32, and this is one more neuron, that is neuron 3. So today I will talk about one neuron only. There we have one more thing, that is b1 bias, b2 bias, and it also has some bias, that is b3. Okay, and I also told you like the output of these neuron will use as an input in this neuron to do further calculation. So let's in this video I will basically focus on single neuron. Okay, let's say this neuron I'm talking about. Okay, so let me create one more giant neuron. Okay, means I'm just zooming this. Okay, so this is a bigger neuron. Okay, so I'm talking about this neuron only. I'm taking this neuron itself. Okay, so this neuron has basically two parts. The first part is summation part, where we calculate a z. I told you what is z. Z is nothing but equation of line, that is, let me show you what is z. So z was nothing but I told you the whole neural network depend on equation of line, that is y is equal to mx plus c. Okay, now when we talk in neural network, it simply get transform, means there are some new variables introduced, but that's only variable. Okay, there is nothing changed, nothing happened much. Okay, that's only variable name we are changing. It will not change the formula of equation of line. Okay, so don't get panic with this. So m get converted to w because we are using weight here, and that's why instead of m in neural network people start using w because they used to call it weight. Okay, instead of slope. Okay, so weight and this is x1 which we are passing, okay, to this neuron. So x plus, and this is c converted to bias, okay, and we started indicating this like y, okay, and this y further indicated using z, which is nothing but if you will simply use to speak, you can say z is equal to wx plus p. So this is nothing but the equation of line, okay. So if you are calculating this z, which is nothing but summation part, okay, so that is basically equation of line, okay, which you calculated so far, and here you have to apply some activation function. This is a symbol of activation function most people use, but if you want to use, you can use any kind of symbols instead, okay. And the symbol I was using, that was sigma, to indicate activation function. And I told you, like, activation function, here I was using sigmoid. One more thing, guys, I'm not talking about activation function only, I'm just talking about the working of single neuron, okay. What is the working of single neuron in a neural network? Let's say there we have 1 crore neurons, okay. So what is the working of single unit of neuron? We are talking about that thing, and that's why I am creating this video. So let me give you an example. So here we are talking about x1 and x2, okay. So what we simply do means, if I want to calculate z here, what I did last time in last video. So if you didn't go through my last video, please go through it once, okay, then you will get a better idea. I'm calculating z1, okay. Here I'm calculating z1. So what is z1? So let me mention it here. So z1 basically use w1 multiplied to x1, because x1 supplied to this neuron. See, this is the line, okay. So w11 x1, okay, multiplying to x1. Similarly, a plus, and this w12, this w12 supplying at the same neuron. So w12, and this is x1, which is again supplied here, okay. So this is x2, and what we have, this is b, okay. So yesterday I told you one thing, weight, bias, these all are random values provided by neural network initially, okay. So keep these things in mind. Initially, neural network provide these values randomly, okay. So this is our what, summation part. So if I will talk about this is what, simple equation of line, okay. So we are simply delivering that equation of line in this neuron, means I'm talking about this neuron, okay, and I'm zooming this neuron here, and I'm just showing you like what happened. So if I'll draw a clear image here, so it will simply, I'm delivering x1 to this and x2 to this with weight 1 and weight 1 2, okay. And here some calculation happened. So this neuron has two part, summation part. So summation part simply calculate what, summation part simply calculate this whole formula. So let me write it down once again, w11 x1, because this is going to combine with this with multiplication operation, and I'm just going to put a plus there, and after that I will pass this w12 multiply to x2, and bias neural network provide from their side. So this is b1, let's say. So I'm simply passing b1 here, okay. So this is our z, which is nothing but equation of line, which is going to be calculated here in this neuron. Now this equation of line looks something like this. So if I have, let's say, two class, okay, two different classes. Yesterday I also create this video, okay. So please, I would request you to go to the last video. So let's say such kind of let me draw it once. Let's say I have two classes only, okay. First one is a green class and second one is, let's say, red class. If I will draw a line, something like this, or something like this, let's say this is a line. Okay, so our value are not classified properly. See, this red and this green came in one class, okay, in one portion, and this blue and this red separated in another portion. Okay, so it is not proper classification. What is the proper classification? We have to classify these two separately and these two separately. So for that, what we have to do? We have to simply transform or change the structure of this line, which is y is equal to mx plus c, or you can say z1 is equal to w1 x1 plus w1 to x2 plus b1. So I have to simply deviate this straight line into some sort of form. Okay, and for that I'm using sigmoid function. So sigmoid function basically once we apply this sigmoid function, so sigmoid function will simply change this whole value, change the shape of this line, and it will simply lie between 0 to 1. Okay, how it will happen, I will show you mathematically also, so don't worry, don't get bothered. In this video only I will show you the mathematical part. So this is 0 and 1. Why this is 0 and 1? So I would tell you, like, sigmoid function always lie between 0 and 1. It never go beyond that. Why it happened? Because of the formula. I will show you the formula also. So what will happen? So sigmoid function simply change this line. Let me pick another color. So sigmoid function basically change this line something like this. Now see, these two green, light green balls separated, and these two red balls get separated because of this deviation of line. So same, this line get transformed into this curve shape because of activation function, and that activation we applied, that is called sigmoid. So first, any neuron calculate the value of z, and that value of z further pass to activation function, which is called sigma. That is a symbol of activation function, but the specific activation function that I'm using here is sigmoid function. But we are not bound to use only sigmoid function. There are other function as well. So I will tell you later on in further classes, okay, like what is activation function, how many type of activation function are there, what are the use case of activation function, and which activation function important for which kind of work. I will tell you everything, so don't worry for that. So now I just want to show you, like, it has a neuron has two parts, the first part and this is second part. So the first part is called summation part. Summation part also indicate using the help of summation symbol. Okay, and if I will show you the horrible form of this summation formula, it will look something like this. So sigma, which looks something like this, like I from 1 to n, and this is what? This is w and this is x, right? So it's simply mentioned wi xi plus b. Okay, so this is the formula. Okay, this is some sort of horrible formula which people don't understand most of the time, because the symbol basically terrified us, right? Sometimes. So that's why I don't want to show you initially, but because most of the time in books we get such kind of formula, such kind of structure, and that's why I mentioned it here. So it's nothing, it's I means how many number of this w1 x1 w2 x2, right? So similarly, maybe there may be n a number of w1 x1 w1 2 x2 w1 3 x3 wn14 x4. Maybe a lot of features we start supplying, like x3 we are also supplying, x4 we are supplying, x5 we are supplying. So with this we are also supplying the weight, right? So in that case we need some sort of equation. Okay, because this is a perfect representation, like from where the I will start and from where it will end. So I start, in our case we have only two input, right? x1 and x2, and w1 and w12. Okay, so I start from 1 and it will go up to 2. Okay, so I will start from 1 and it will go to 2 only. So if you will expand this formula, you will get the same output. Okay, so this is simply the formula of summation part, which is being used by neural network to do some calculation, because deep learning and any kind of AI stuff depends on equation of line only, and there is activation part also, because whatever we are creating in machine learning, deep learning, this all happen because of the help of neurons, and that neurons come together to form neural network, and that neural network gives us a output, a prediction. Okay, so it simply try to adjust the line according to our data to make our data categorize equally. Okay, so I just want to show you a mathematical operation on this, and for that I have to erase this. Let me erase this part. So I'm just erasing everything, guys. Please make a note of it, otherwise you will definitely get some problem, means it will tough to understand, because you cannot memorize each and everything in one shot, right? So I would request you to make a note of these. Okay, all right, now I want to do some mathematical operation. Okay, so let's say I have x1, which is first feature, let's say this is 2, and this is x2, which is, let's say 3. Okay, which is my input. Okay, so I want to calculate the summation part. What I want to do, calculate the summation part. I'm doing it manually, but in a neural network it happens automatically, because there we have predefined algorithms, right? And there in algorithm we have a huge concept, like huge amount of formulas mentioned. Okay, so summation part of neuron I'm going to calculate. So how can I do this? So simply I will say, okay, one more thing, I also need weight, right? W12, sorry, W11, that is the weight. See, we have a weight here. This weight I'm talking about, W11 and W12, I have to introduce. So in a neural network, it introduce automatically, randomly, right? And there's also one more part, which is bias, which is also introduced randomly. Okay, so for now, let's say I'm saying this 0.2, and I'm saying this 0. Let's say 3. Okay, and bias, let's say bias is 2. Okay, so I'm just taking one example just to show you like how mathematical formula will work. Okay, so if I will go for this, I have to demonstrate you W12 and bias also, which is B1. Okay, so what I supposed here in W11, I supposed here like 0.2, right? So I will mention here 0.2. I suppose W12 as 0.3. I'm mentioning 0.3. In the B1, I am assuming it is 2, and that's why I'm mentioning 2. Now I have to calculate summation part. Okay, so summation part formula is what? X1 multiply to W12, sorry, W11 plus x2 multiply to W12 plus B1. Okay, so I already defined all variables initially. All right, so now if I will run this, and if I will store it inside a variable, let's say z, and I will print it, I will get some sort of calculated value, which is 3.3. Now I want to apply activation function on this. So before that, I should know what is activation for function formula. And in activation function, we have a lot of activation function, but I'm talking about sigmoid activation function. So in sigmoid activation function, what kind of formula we have, I have to show you first. So let me mention it here. What is the formula of activation function? So activation function formula is sigmoid activation function formula. Okay, I have to show you. So let's say this is belongs to one class. Okay, means there are two classes, right? See, green balls and red balls. So there are two classes. First class is green ball and second class is red ball. You can also say first class is red ball and second class is green ball. There is no restrictions. Okay, but let's do this. So if I will say 1 upon 1 plus e to the power minus z. This is the formula. This is basically the power. Okay, so I have to use this formula to convert this line into a deviated form, something like this. Okay, because initially this line was something like this, right? But we are using activation function to deviate the line to get classified our value properly, as I mentioned in this picture, right? So that's why I have to apply activation function on this z now. So let's see how can we do this. So first of all, I have to calculate the value of E. So what is value of E? Because E is a universal constant, I have to get the value. You can do the Google, but I know the values. So E value is 2.71828, which is Euler constant. Euler was a scientist or mathematician who introduced this constant. Okay, so you can easily get on internet. You can easily go and find out the value of E. You will get the same value, 2.71828. Okay, that's the Euler constant. So I want to use this formula to convert this value, okay, into some deviated part. And this value, this 3.3 will come between 0 and 1. Okay, keep this thing in mind. See, I mentioned here that sigmoid function always lies between 0 and 1. And how it happened, I will show you. So let's see. I want to use this 1 upon in bracket, because I have to divide numerator the whole using whole denominator, and that's why I'm using bracket. I will mention each and everything inside this bracket. So I will mention 1 plus e to the power, because e has some power, and that's power is nothing but the z. Okay, and there I put a minus sign, right? So that minus I have to keep there, right? So let's see. So how can we mention power in Python? Using double asterisk or using power function of math module. Okay, so I'm using 1 plus e asterisk asterisk just to mention the power, because double asterisk means power. Okay, and I'm simply mention here minus, and I'm putting the value of z, which is 3.3. Okay, so now if I will run this, I will get some sort of value, and that value will lie between 0 and 1. See, so it is asking me, you didn't mention the value of e, and e value is I have to define, right? So let me define it here. E is equal to 2.71828. And I'm also doing one more thing, just to make it more dynamic. I'm mentioning here minus z. Okay, so I cannot mention here minus z like this. I have to apply, let's say I'm saying 1 into z. Okay, so I will simply multiply something like this. Okay, and now I have to define the value of z, which I already calculated above. See, z value is 3.3, but just to make it clear, I'm also mentioning it here. All right, so once you will run this now, you will get the output, and which is lie between 0 and 1. See, I'm getting a value which is 0 between 0 and 1, and why it is happening. So let me give you a simple example. It is very complex for now, so just to give you a simple example. Let's say if I am dividing 1, which I'm doing here, 1 I'm dividing using a big number, let's say, or a small number, it always lies between 0 and 1. Why? Let's see with some example. Suppose I'm dividing 1 by 5. What I will get? 0.2, right? If I will divide 1 by 10, what I will get? 0.1. If I will divide 1 by 2, what I will get? 0.5. Okay, so this is the whole operation which we are performing. Okay, all right. So see, there is nothing like you can use minus. How can you get minus? Think about it. If you will multiply or get power of any positive value, okay, e power is what, e value is what, 2.71828. If you will do power of this, okay, let's say power of -1, then also you will get positive value. You will never get negative value in denominator. So don't think about negative values, okay? Like you can keep negative value in denominator. You cannot use negative value because negative value never happened because of this Euler constant. Okay, you can try it or try it on your own. Okay, if you will explore, if you'll put some values like in power -1, if you will keep it, you will not get negative values. If you will do like 100 -100, you will not get negative values. Okay, it simply happens something like this. Once you will mention minus here, it will simply go down in denominator. Okay, and their power will become 100. But again, when you will divide these two, you will get a positive value only, not a negative value. Okay, so formula is defined something like this. Okay, you will never get negative value in denominator, so you will never get less than 0 kind of values. Okay, keep this thing in mind. Now that's why I'm getting the value between 0 and 1. One more thing, it never touch 0, never touch 0. That's why yesterday I also told you, like when I was creating this graph, I told you like it is between 0 and 1, but I never said it will touch 0 and 1. I said it will touch somewhere at infinity, negative infinity and positive infinity, right? But none of the scientists in the world define infinite values. Okay, and that's why that we assume somewhere we will find negative infinity or and positive infinity value. But so far, means since the mathematics started, nobody is able to tell you like what is the infinite value or infinity value. Okay, and that's why this output, the sigmoid output, will never touch this 0 and 1. It always try to approach. Okay, when you will go in limit or calculus, you will get such kind of concept there. I will also teach you that, don't worry. But this has happened in the mathematics. See, deep learning is all about mathematics. If you are good in mathematics, you are good in deep learning. If you are not good in mathematics, you are not good in deep learning, because there we have to manipulate most of the time the formulas. Okay, and we have to keep this thing in mind. Like many people who are doing the AI stuff nowadays, most of the people come from mathematical background. I'm not making you guys hopeless who belongs to non-technical field, right? Non-mathematical background. I'm not making them hopeless. I'm just saying you the truth. Okay, so the thing is, if you are not from mathematics background, don't worry. Just go read 10th, 11th, 12th mathematics, and that is sufficient to understand these things, because these all things mentioned there in your book. Okay, and that is not tough. Means throughout this tutorial, I will use such kind of mathematics, but that mathematics will very much easy. It will be covered between integration, differentiation, algebra. Okay, it will get covered in these only. Okay, in matrix it will get cover everything. So everything is there, means in 9th, 10th, 11th, 12th mathematics book, and you have to simply focus on differentiation, integration, algebra, matrices. That's it. So guys, hope you like this video. If you really like this tutorial, please give me a thumbs up, like, share, subscribe, share with your friend families, and please focus on your math. This is a kind of suggestion for you, I can say, and that will really helpful for you to understand. So please do like, share, subscribe, share with your friend family, and give me a thumbs up. Thank you guys. Thank you for watching. Stay tuned with me. Thank you.